Hi YouTube, Steve here. This video is in preparation of the fabrication and building of my weld positioner. I found a need to weld round things, cut round things. So instead of trying to buy something that's not big enough, or buying something that is big enough but cost way more than my budget will allow, I've decided to build my own. So my first step in preparation here will be my motor drive unit, and I'm going to use an AC/DC gear motor. It'll be a Dayton. It's made by Dayton. AC/DC gear motor. It's also called a universal motor. So I'll show you here what I'm going to be using. And it's a small outfit. I believe it's 1/15 horsepower. It is reversible, and it's got a wiring diagram right here. It's a 4-wire motor. It has yellow, blue, red, and black wires. Here's the gear head. It's a mounting base so that it can be mounted. This here is a Lovejoy style coupling, which will come off eventually, and I'll be using a timing belt and timing pulleys for my drive to the spindle. If you look closely, the model number and wiring diagram is on there. It talks about, okay, when you want to reverse it, you switch the red and the blue, the red and the black with the blue, if I remember right here. To reverse rotation, interchange blue and black. Yeah, you interchange the blue and the black with the red. These motors, I believe, is wired in series. It's a brush type motor, similar to your drill motors, saws. It's not a capacitor start. It has no capacitor, so it's a small motor, and I'm going to show you the simplest way that I found to wire this to reverse it without having to change the wires. The simplest way that I have found is using what is called a double pole, double throw toggle switch. I'm using what is called a maintained switch, so that when you throw the switch, it stays. Put it back to the off position. You flip it the other direction and it stays for the other direction. So with this switch, one direction will be forward. This is an off position, and then this is the reverse position. They also have these same type switches that are called momentary, that when you push on this, you have to hold it to reverse it. And which that's not what I'm looking for. I'm looking for something when I switch it, it stays and it continuously goes the same direction. When I turn it off, I wait till the motor stops and reverse the switch to reverse the motor direction. And it stays in that position and it goes in that direction continuously. So as I proceed here, I will try to explain how to wire this switch. I have come up with actually four ways. I've come up with 4 ways to wire this, and one popular way is using the drum switch style, the reversing drum switch style, drum switch control. I had this laying around project a couple years ago that I ended up not needing after I bought it. So it's been in my cabinets up above my workbench for as long as I can remember here, and I still haven't used it. I think I give about 30 or 40 bucks for it years back, and now they are probably 60 or higher, 50, 60 bucks higher. So these are the most popular ways to reverse motors, and I've decided that the unit is too big because I want all the controls in one small handheld box so that I can use it and walk around my outfit, around my equipment, around my parts. As you can see here, just the drum switch is a handful, and they're normally mounted stationary to whatever equipment it's governing, and it doesn't normally go into a handheld box to be carried around. So this is one way to wire one of those. These drum switches, they make them in different configurations. So if you do decide to use a drum switch, here is the type of drum switch that works for this AC/DC motor. This is a wiring diagram of how it would wire. Now, like I say, not all drum switches have the same type of construction and same switch throw. So if you want, you can look this over and determine if that's what you want. And since I want to have a handheld control box, as you can see here, this is approximately a 4 by 6 by 3-inch box. What I'm going to do is I'm going to put the rheostat, the variable speed control knob in here. I'll have a inline power switch, and then I'll have my reversing switch, and then I'll have two panel lights. One for when I turn it on, it'll have a green light. I'll have three lights. One for turning it on a green light, and then a red or different colors for the clockwise and counterclockwise rotations. Now to wire this double pole, double throw switch, which the switch has 6 posts. It has 6 posts, And normally this is where the center two posts is where you hook the AC positive and negative to. Don't necessarily have to put the AC positive and negative on a switch. Normally you can take and run the negative to the yellow wire. You can run the negative to the yellow wire here and leave it connected to the yellow wire. All you're doing is breaking the AC positive circuit. So if you look here, I've connected the AC positive to one side of the double pole switch. So this side here is one pole, and then this side over here is the other pole. Which when you throw that switch up, it connects these two down here. And when you throw that switch down, it connects these two, or these two, yeah, these four. Connects these four, and then it connects these four. So as you can see here, when you throw it up, it connects here. And when you throw it down, it connects here. The switch works opposite. When you're throwing it down for one direction, it connects these. When you throw it up, let's say, it connects these. Because this points down. This points down. This points up. So it's connecting these four here. When you throw it up, it connects these four down here. So if you look here, I've connected the red here, the AC positive. When I throw it one direction, it connects the red and the black wires together. So on that wiring diagram, it connects the red and the black together. This jumps over here with a jumper wire back. The jumper wire comes from this post, connecting over here to this post, to the black lead. And as you can see, the yellow wire is connected. I don't have it shown here, but the yellow wire is connected to the AC negative. And when you throw it up, it connects these four posts here. And then with the jumper wire from this post here, it connects to the blue. As you'll see here, I'll demonstrate by hooking up the AC positive to an outlet and an AC negative, which will connect to the yellow wire. I'm going to insert the yellow wire from the motor into the ground wire of the receptacle. And then this orange wire here, just for bench testing, is the one that's hooked to the AC positive on the switch. I'm going to hook it into the hot side of the receptacle. And since I wasn't paying attention, I had it turned on. Okay, now we are in the straight position. We are in the straight position here, center position on the switch. And I'm going to switch the circuit or switch the switch to one side. As you can see, it's turning, let's say, clockwise. I turn the switch to the center position and it stops because it disconnects all connections in the switch. Now as I flip it the other direction, you'll see that it turns what I call counterclockwise. I believe that's the easiest way to wire this motor. And I believe it's about the cheapest outfit, cheapest drive that can be purchased. There may be cheaper ones out there, but with this Gearmotor I have, as it is, 100 inch-pounds of torque through the gearbox. I plan to 3-to-1 ratio gear reduction with the timing belt and timing pulleys to slow it down even more. With no load, this Gearmotor gives me 66 RPMs. With some load, it may drop down to 20. So, and most weld positioners only need approximately 6-7 RPMs maximum. I believe what I'll actually need will be like 1 revolution per minute, or maybe even less. So with this 3-to-1 gear ratio, I may even go to 4-to-1 gear ratio to even slow it down a little farther. That's something to be determined down the road. But with the gear reduction, I believe the torque will go up. So I don't believe there will be much loss in RPM speed once you put a load on it. Most of my stuff that I'll be rotating will be centered, well balanced, so it should be on an equal basis on rotation. Very little resistance in the weight, so it should turn more or less with no load on it. The only load that might be on it would be through the bearings. I'm going to use pillow block bearings on a 2-inch spindle. So this should turn out to be really nice. As you want to watch and follow along, this build will continue on until a completed weld positioner is done, and I hope to entertain, I hope to instruct, I hope to be able to give you direction in maybe building your own. You can leave comments. Don't forget to subscribe so that you can follow along. And if you like what I'm doing, and if you like what I'm talking about, hit the like button. We'll see you in the next videos. Thanks.